In section 6.2, we further study the way people come to make decisions through the study of game theory. I'll introduce the notion of a game and explain its role in modeling decision making. I will also show you how to construct and interpret a payoff matrix for a game. This is the basic tool for modeling a decision process via a game. Our study of game theory is motivated by the interconnected nature of many sustainability issues. In particular, solving sustainability problems tends to require cooperation among different actors. For example, in order to address water shortages in the western U.S., many states will need to work together. Preventing the extinction of endangered species, such as migratory birds, may involve multiple countries and NGOs. The Paris Climate Agreement, signed in 2015, was an agreement among countries around the world to undertake efforts to combat climate change. The agreement is non-binding and fundamentally relies on the cooperation and buy-in of the countries involved. Game theory can be useful for modeling such scenarios because it models decision-making when individuals are part of a network, where the individual's decision is affected by the actions of others in the network. Game theory models will allow us to understand when the parties involved are likely to cooperate or not, including when one party might be motivated to free ride. Game theory applies whenever there is some strategic interaction between two or more players. The players are agents who make decisions by choosing a particular strategy for the game. The outcomes for each player depend on the decisions of all players. Actual games, such as chess, satisfy these criteria and can be modeled by game theory. But the power of game theory is that it can be used to describe and analyze a much wider set of interactions between decision makers. Let's look at an example from advertising. Apple and Samsung are the dominant companies in U.S. cell phone sales, and combined have about 2/3 of the total market. Imagine that they are the only players in the market and are deciding on an advertising budget. To simplify the scenario, suppose the two companies currently make $5 million each. Both need to determine whether they should advertise. For each company, advertising costs $2 million and captures $3 million from the competitor, provided the competitor doesn't advertise. What should the companies do? In this example, the agents or players are Apple and Samsung. The two companies are each choosing between two strategies, either to advertise or not advertise. We can represent the outcomes of the various strategies for each player in what is called a payoff matrix. This is a table that shows the payoff or outcome that each player obtains from a given combination of both player strategies. For example, suppose both Apple and Samsung advertise. Then each company maintains its current share of $5 million, but spends $2 million on advertising. So each company has a net payoff of $3 million. Here, the first three represents the payoff for Apple, and the second three represents the payoff for Samsung. Now suppose Apple doesn't advertise and Samsung does. Then Apple loses $3 million of its market share, resulting in a payoff of only $2 million. On the other hand, Samsung gains $3 million in market share, so it takes in $8 million. But since it is spending $2 million on advertising, its net payoff is $6 million. If Apple advertises and Samsung doesn't, we get similar payoffs, but in reverse. Lastly, if neither company advertises, both companies maintain their original market share. Then each company has a payoff of $5 million. The payoff matrix represents the different strategies of the players and how the outcomes depend on both players' strategies. How does this help us understand the decision-making process? The basic idea is that making a decision depends on identifying the optimal strategy. We describe a strategy as dominant if, whatever play the opponent may make, it is at least as good as any other possible response. We can analyze the advertising payoff matrix to look for dominant strategies. Let's suppose that Samsung chooses to advertise and Apple knows it. Then Apple can analyze its strategies to see which would benefit it more. If Apple advertises, it has a payoff of $3 million. Whereas if it doesn't, it only has a payoff of $2 million. The better option is to advertise. Now suppose that Samsung chooses not to advertise, and Apple knows that. Again, Apple can analyze its strategies to determine that it optimizes its payout by choosing to advertise. The better option for Apple is to advertise again. We can see that whichever strategy that Samsung chooses, the optimal strategy for Apple will be to advertise. This gives the dominant strategy. To determine an optimal strategy for Samsung, we go through the same reasoning but in reverse. Let's suppose that Apple chooses to advertise and Samsung knows it. Then Samsung can analyze the strategies to see which would benefit it more. If it advertises, it has a payoff matrix of $3 million. Whereas if it doesn't, it only has a payoff of 2. Here, the best strategy is to choose advertising. Now suppose that Apple chooses not to advertise and Samsung knows that. Again, Samsung can advertise its strategies to determine that it optimizes its payout by choosing to advertise. The best choice for Samsung is to advertise in either scenario. This means that advertising is the dominant strategy for Samsung. So we end up in the situation where the dominant strategy for both companies is to advertise, even though this does not result in the highest revenues for the two companies. We'll return to this in the next video. Let's look at a sustainability example. Vann Newkirk, a writer for The Atlantic, applied game theory ideas to understand various scenarios related to climate change policies. West Virginia and Kentucky have among the highest per capita greenhouse gas emissions in the U.S. How might they try to collaborate to cap their regional emissions? To understand the potential payoffs for the two states, Newkirk proposes evaluating the value of environmental resources, the future costs of climate change, the degree to which emissions policies can affect those future costs, how much those policies cost, and how much each state can actually afford to spend or lose. These various measures can be combined into a single measure of utility. One scenario we might consider is a short-term assessment policy. In the short term, the environmental threat is low, and the costs of implementing policies to protect the environment are high in comparison to continuing efforts to exploit resources. The payoff matrix outlines two strategies: enacting protective policies or continuing to exploit resources. Continuing to exploit resources could involve opening more coal-powered electrical plants to maximize energy output and profits, whereas protective policies could involve shifts to greener energy production. In this payoff matrix, the payoff values are hypothetical and don't have units, but keep in mind that a higher value corresponds to greater net benefits. Let's try to identify the dominant strategies. If both states enact protective policies, they each have a net utility of 1. But if West Virginia enacts a protective policy and Kentucky continues to exploit resources, Kentucky's utility increases to 3. On the other hand, if West Virginia exploits resources, Kentucky's best choice is still to exploit resources. We can see that Kentucky has higher utility if it exploits resources, no matter what strategy West Virginia employs. In other words, exploitation is a dominant strategy for Kentucky. Similarly, West Virginia maximizes its utility by continuing to exploit resources. Thus, game theory predicts that in this scenario, it's inevitable that both states will continue to exploit resources. Let's consider an alternate scenario. Suppose the two states are near ecosystem collapse. In this scenario, the environmental threat is high. Moreover, as resources become scarcer, there are diminishing returns for exploitation. In this scenario, if West Virginia enacts protective policies, Kentucky benefits by also enacting protective policies. If West Virginia continues to exploit, it is still in Kentucky's best interest to enact protective policies. In other words, the dominant strategy for Kentucky is to enact protective policies. Using similar reasoning, we get that the dominant strategy for West Virginia is also to enact protective policies. This suggests that Kentucky and West Virginia will eventually move toward enacting protective policies as they move closer to ecosystem collapse. It might be possible to shift states to this decision sooner by shifting their focus from short-term to long-term assessments, or by shifting the inputs to their utility calculations.